Thank you.
I am ready to. Hello, everyone. I just wanted to be able to say hello and wave before I turn off my video. So thank you for joining us today for this session. Lisa and I will be co-presenting, as you probably heard, because she was with you on the previous presentation. So I will shut off my video so it doesn't interfere with our broadcasting. All right, so today we are here to present developing masonry structures to meet the 8th edition of the 2023 Florida Building Code. It is being presented on behalf of Florida Masonry Association, Old Castle APG, and Five Foil Company, as well as the Florida Concrete Masonry Education Council. Myself, as some of you probably know, I may have been in front of some of your firms this year or in previous years, but I have now reached my basically 40th year in the construction industry.
Woo, woo.
I've been around the block a little bit. But I have a background in various building materials. My career has basically focused on helping consult architects, engineers, and any kind of construction professional that gets involved in selecting products for their projects. As you can tell from my current title, I have continued down that path as Senior Director of Architectural Resources and Education for Five Foil. Just celebrated 19th year with Five Foil this last January. And prior to that, I had some experience in the flooring side of the equation, but I basically rep a product line now that involves materials that incorporate metallic films or foils. The advantage of those materials is to help address radiant heat transfer. It also, obviously, depending on how the product is used, will help you address conduction and convection. So you are getting addressing all three forms of heat transfer, but the product line itself is expanded into specialty products such as skiff barriers, and we have air barriers that are reflective. We still have our radiant barrier lines and our insulation facing materials. But the product that we're focusing on today in the presentation is going to be the masonry wall applications, specifically our multi-layer products, AA2, M Shield, and VR Plus. Those products do attach to the framing, and they create your resistance to heat flow, creating an R value based on the depth of the cavity. So for instance, if you did an AA2 on a 3/4 inch footing, it would be an R 4.1. If you did an M shield, it would be the same because they're structured exactly the same with a single layer foil that opens into the cavity. However, if you step up to an 1.5 inch cavity, with AA2, you're up to a 5.1. And then if you add another layer of foil, which would be the VR Plus, that would be a 6.5 R value. So the depth of the cavity and the number of layers of reflective material will determine your R values for the masonry wall applications. The other applications you see here are what I briefly mentioned: radiant barrier applications. We have the skiff room applications, and last but not least, we have a metal building solution for both new and existing. And with that, I think we'll pass it back to you, Lisa.
All right. So just quickly, we already discussed some of the product lines at a glance, so I'm going to be very quick about this. But my company, Old Castle, is actually owned by a parent company, CRH, based in Dublin, Ireland, Cement Roadstone Holdings. And in North America, we have 3 different divisions. We have the Architectural Products Group, we have our Infrastructure Group, and we have our Materials Group. So again, within just my Architectural Products Group, which does our Belgard, our hardscapes, we have Echelon, which is our vertical masonry, segmented retaining walls, all kinds of things. We have almost 200 locations, but we're really just one big company. And I will say, during COVID, I think is when we really got together as one company. Just knowing what I do in Florida, I have others that do the exact same things on other parts of the United States and in Canada. So it really can make a project go very well, depending on where you're designing that from. So our due diligence slide, basically Five Foil, Oldcastle APG, and our Masonry Association were all registered providers of the AIA continuing education system. So we will make sure that we conform to those requirements. So our course description today, concrete masonry coupled with effective insulation solutions are valuable strategies for our ever-changing design environment. So hopefully after this 1-hour HSW presentation, you all will gain a better understanding of the compliance paths used for meeting the 8th edition of the 2023 Florida Building Code, all regarding mass wall assemblies. So we also this course reviews the criteria for selecting proper insulation remedies. We're going to address air and vapor transmission and just hopefully discuss and have a better understanding of some of the methods and procedures to ensure a more sustainable and resilient building envelope. So our learning objectives today are to design an effective and economical thermal envelope that meets the requirements of the 8th edition of the Florida Building Code, to select the best insulation solutions to achieve those energy efficient mass walls. We'll address vapor transmission and air leakage, and also utilize some of the strategies discussed to show you how we've achieved a more sustainable and robust building envelope. So we're going to start with some of the very basics. When we talk about the path to IECC compliance, some of the considerations is what kind of project am I designing? Is it a commercial or is it a residential? Where is the project located at? Also, what type of wall systems? Today we're talking about mass wall systems, and there's several to choose from. So what type am I going to choose? And then which compliance pass is going to actually allow me to achieve my end result? So the IECC is the International Energy Conservation Code. It is incorporated by the IBC, which is the International Building Code. It relates to both commercial and to residential, and it really draws on ASHRAE very much. Now, the good thing is our code for Florida, we actually have gone a step further. Some of the other states in the United States have done this, but not very many. But we actually now have the Florida Building Code. I don't know how many of you were around back in the day when it's actually post Hurricane Andrew, and we had several different codes. Andrew came and it was all based on an Appendix D. Andrew came through. Of course, it just hit and smashed the east coast of Florida, 1992. And that's when we actually had a little stricter code, if you may, for the East Coast, and a little more standard code for the West Coast. But as we've seen, hurricanes don't just hit the East Coast, they hit everywhere. So fortunately, Florida now has one building code, and that is the way to start to get things just more and more compliant. So under the IECC code, there's the Group R, which not only classifies the building's use and occupancy, but it also helps identify fire safety and other hazards that are involved. So when we talk about residential Group R, R1, hotels and motels, R2, apartments and dormitories, R3, single detached homes and duplexes, and R4 is assisted living and care facilities up to 15 occupants. So bear with me 1 minute. My office is having a little bit of work done and I can only hear the saw in the back. So when you talk about residential Group R, primarily transient in nature, where Group R2 is primarily permanent in nature. Also Group 3, primarily permanent in nature, as long as it's not covered under 1, 2, or 4, and then Residential group R4, again, residents who reside on a 24-hour basis in a supervised environment. So now we're going to jump and we're going to address how actually do concrete masonry units address the energy efficiencies in the building envelope. So there's three ways. We have thermal mass, we have thermal resistance, and we have thermal conductivity. So thermal mass is the ability for the material to absorb that heat energy. And honestly, it's applicable to all the climate zones, but you really find the benefits in the warmer climates. So then thermal resistance, also known as the R value. This, as you know, is the steady state thermal characteristics. So when you discuss concrete masonry units, the size of the unit, the type of the unit, and the density all play a very big part. So does the insulation and where that insulation falls. Your finished materials, so depending on if it's a single white, if it's a cavity wall, or if it's a thin veneer that's adhered, and then the grouting schedule. So then the inverse is the thermal conductivity. So this is the rate at which the heat passes through a material. So again, your size, your type, and your density all play a part, as well as temperature condition and the moisture content. So again, when we talk about thermal mass, it's just the fact that it actually, the CMU products hold that heat energy. Now, it doesn't mean just heat, it's cool too, but it holds that energy for longer periods of time. So it's just important when you think about having to evacuate, it's just one scenario. Also, it also helps of the reduction of cooling and heating demands, which means dollars, and it also relates to less CO2 emissions into the atmosphere. So there is really a whole bunch that goes on behind the scenes. So thermal resistance, as I mentioned, the R value, it's typically expressed as the thickness of the material divided by thermal conductivity. But again, the R value just in itself, super important, but just to make sure that when designing with a concrete masonry unit, you're taking the fact of that thermal mass in there too, because you can design and have more R value, but there is a diminishing return at some point. So you're just going to over design and it would cost too much. So thermal conductivity, again, it's the rate at which heat passes through. So the thermal conductivity of a masonry unit is higher than the thermal conductivity of air. So scientifically, this is why we can stay inside for longer periods of time, depending on hot or cold, without having to evacuate. So I talked about compliance methods in the past too, but the prescriptive requirements, pre-assigned minimums for each component of the building, it's prescribed, it's black and white, it's like a recipe. This is the way that we're going to do it. But there's also performance-based compliance paths, which allow a little bit more customization. It assigns points for each selection. So sometime you might build a little better mousetrap with performance. So the climate zone, definitely this map, I have it, I think, in every single presentation I've ever given. And there's several different softwares that are on the market, not just ComCheck, but there's ComCheck, there's Energy Gauge Summit, there's several that you can choose from. So the same table that I had on my last chart strictly is showing you, we're talking about mass wall assemblies. So if you're talking about a mass wall and we're in zone 2, group R, if you're designing with continuous insulation, your R value is 7.6. But as I mentioned, sometimes the design may not demand that. You can have the same components, but just not have to have continuous insulation with designing with the inverse, which is using the U factor table. So that's just another method, and designing less than 0.123 using the U factor. So you have R values and you have U factors. So some of you might be asking, what's a mass wall? So according to NCMA, and the new nomenclature is CMHA, Concrete, Masonry, and Hardscapes Association. Goodness. But again, you get to the website ncma.org. So they consider a mass wall that they have two characteristics. It's the weight of the wall and it's the heat capacity of that wall. So I have a couple of illustrations. On my left, I have a double white. On the middle, a single white, and on the right, a surface bonded. So on the left, double white, my illustration reflects that this is a substrate of some sort, and of course I plugged in block. We have a defined cavity space, and then we have an anchored veneer. And that veneer could be brick, it could be block, it could be a full bed depth stone. For single white, my illustration, I am, this could be perhaps an architectural block wall, just single white wall. This could also be a clay product. They do make clay structural products as well. It could be painted or it could be stucco and painted. This is what I refer to today with my single white illustration. And then lastly, surface bonded. And for surface bonded, here I refer to simply thin stone or brick or block that is directly adhered to a substrate. And when I say directly adhered, it does matter what your substrate is. So there could be a couple different, you could have lath, perhaps you don't. You're going to have cement board, you're going to have a weather resistant barrier, but all in all, that thin product is directly adhered. So in an insulated cavity wall, one of the benefits in Florida, especially of building with cavity wall systems, you can insulate more towards the outside. So where the dew point falls is excellent. So your R value is great. You have your veneer, you have your substrate. If you want continuous insulation, that is not a problem in a design like this. Water management's also great because if you do get any type of water mitigation, it's typically not coming through the face of product. They're little pinhole cracks in the mortar. So it would then find the flashing, which you don't see in this illustration, and then it will escape through the weeps. The one downfall, you do have a cost factor because in essence, you're building with two walls. Whoop, excuse me. In this case, the insulated in a single white application, here I do show insulation that is actually in the cavities. That is one method. You can also insulate in the interior. You can also do both, depending on what you've got. This is actually my picture. I'm going to take that back. This one is not insulating within the walls. This is actually grouting, but you can insulate within the cavities too. Continuous insulation would all have to be done on the interior. Water management's not bad. You can do that same rain screen principle by integral water repellent, a post-applied water repellent because this is a block, and you're going to have flashing and weeps. And your cost is actually better in this case because you're only building with one wall system. And there's multiple ways for insulation, and Jan is going to go into more depth in just a few minutes. And then on your adhered veneer, your R value is only as good as your substrate. So this is where it really comes to play. Now, I've seen one or two designs where they've had an a continuous insulation, but it's typically going to be on the interior side of the wall. Now, water management for a thin adhered product is actually very good. And one of the reasons it's very good is because now, and we have been promoting this for quite a while, you do have sometimes a type S. We recommend a polymer fortified mortar. It's stickier. It's got these polymers in it. So it really enhances that suction power, if you may, between the substrate and the properties that you need and that thin material being directly applied. Now, cost is not bad. Some of the thin products are pretty reasonable, but B is also because of the labor. When you talk about a single white wall or a cavity wall system, you're going to have a masonry contractor that is going to do that work. But when you have a thin applied material, you can actually pull in, say, a stucco contractor, or even somebody, a painting contractor, depending on what their scope of work is. So it not only allows masonry contractors to vie for it, but you have other contractors, which makes the pool a little bit bigger for the labor, which in turn will bring down the cost. So again, this is a snapshot of the slide that was pretty hard to tell, but I was only illustrating on table C402 if you have an R value, or table C402 with the U factor method. So ComCheck I mentioned too. ComCheck's a very popular program as well as EnergyGauge Summit in order to use this software for more of a performance-based. And again, Jan's going to go into a few details of here's a prescriptive and here's a performance. So it kind of gives you an idea of using both methods. So to wrap up learning objective 1, the energy cost savings to Florida, if we continue on the path that we are going, by 2030 in Florida alone, we'll save homeowners, and businesses over $700 million. But if you look at as a whole through the United States, if we can continue progressively through 2040, we're not only going to save over $126 billion, we are going to save over 800 metric tons of avoided CO2 emissions. All right, Jan, you ready? Jan?
Yeah, sorry, I was trying to answer a question.
Oh, okay. I'm like, uh-oh, did I just disconnect from the world?
All right, no, just let me finish this. I'm sorry, guys. I was in the middle of a thought there, so. All right, apologize for that. All right, so next section, we're going to get into the actual insulating options for meeting the code. I'm going to follow the same formats that Lisa provided. As far as types of structures, we'll start with the double Wythe. Again, this one is definitely the way that you can insulate on the exterior side with a mass wall system. But double Wythe is not as common in Florida. Now, when you get into Georgia and, go like a couple states north, you'll see the brick secondary wall being a more common practice. So a lot of the insulation is actually done on the interior side because we're usually putting stucco or paint or some other finished masonry structure as our finished exterior. Again, we're talking specifically about mass wall at this time. So in this case, with the double Wythe, you can insulate on the outside, and in order to meet the 7.6 continuous insulation under group R zone 2, you're going to be 1.5 foam board is going to be what you need. Now, keep in mind, if you want to add some extra performance capability to that board, you can put a foil surface on it, and it will help address radiant heat transfer and keep that radiant heat out as well. So you'll get a couple of different characteristics from it. But so that would be one way you could go. Okay, next.
Oh, sorry. There we go.
So now that we're talking about the next option was single Wythe, we're going to be moving that insulation to the interior side of the mass wall. So you would be adhering or tacking the rigid board to that exterior wall, and the framing would go over top of it. Next. So in this case, you can see the scenario where that rigid board is now on the interior side of the CMU in this particular illustration. And again, you would still have to use an 1.5 board to meet the minimum requirement under prescriptive of 7.6. Now, again, you can do a foil surface, but please keep in mind the foil facing, in order to help block radiant heat, should always face an airspace. So it needs to face inward towards the drywall. If you flip it the other direction, it's going to be nothing more than a vapor retarder. So specifically, the foil or reflective surface would face that cavity, that air cavity, towards and face towards or inward towards the drywall. In addition, it is important to understand how to read some of the performance data sheets that are provided by the insulators when it comes to the R value of the board itself. In this case, you can see on the left-hand side, there's a thickness and then you have an R value. That's just for the board itself. And that's what you want to use when determining the thickness of your board to achieve that 7.6 continuous insulation. You'll see that it does require you to go all the way up to the 1.5-inch board to get to the 9.3, which would be in excess of the 7.6. On the right-hand side, what you're seeing is the board plus the reflective airspace. And then again, the size of the reflective airspace will determine how much additional is added in order. And that's actually your total R value you're achieving there for both. So in other words, if you had a 3/4-inch airspace in that same board, you're going to be at an R12. That's just to help you read their information more clearly. In regards to the actual masonry wall structure and insulating with multi-layer reflectives, these products are structured with expanders that open the layers into the cavity. They attach to the framing and they create what we call reflective air spaces. And as I mentioned earlier, the depth of the cavity and the number of layers is what determines the R value. So we're on a 2x2 frame cavity in this example. And when you have a single layer that opens into the cavity, that creates 2 reflective air spaces. That will be an R5.1 on an 1.5-inch cavity. And you add that extra layer, so now you have 3 reflective air spaces on the right-hand side. That's going to take you up to an R6.5. And that's because of that additional layer of reflective material that you added. Okay, next. In regards to the attachment, when you have wood, you staple. When you have metal, you adhere with either a spray adhesive or you can order product with an integral tape tab and you can just peel off the paper and attach it to the framing. It just has to be held in place long enough for the drywall to go into positioning. And you are covering the top frame and pulling the material all the way across from one framing membrane to the other. So all the materials are designed to fit 16-inch on center or 24-inch on center. So you basically attach on one side and pull it across, but you're also covering your top framing and bottom framing with these materials. That still allows for those inner layers to open into the cavity. Next. Next, yeah. In regards, just put them all up, Lisa. So in regards to these solutions here, I'm just basically showing you from an installation standpoint some of the key questions we normally get with multi-layer reflectives. When you have a smaller cavity, you want to install the larger cavity first. To the left of the window there, you see the darker color section. That's the smaller irregular cavity. So you're going to go to the left of that, put in the full-size cavity. Then you're going to start on the window side of the darker blue and pull it across onto the side the section you just installed, and you attach it at the framing so that you hold it in place, and it will open up the expanders on the one side of the product, and you're still getting as much opening as you possibly can on that smaller cavity. If the framing turns horizontally, you want to follow that framing horizontally, and around any penetrations, you just cut net. And most of the building code officials are probably going to require you to foam around that block or tape. You just want to make sure according to our installation guidelines is that you do not see if there's another insulating material behind it, you don't want to see that, or you don't want to see the back wall. So from the standpoint of these different steps, this is all part of our installation guidelines. So next.
I'm coming. I was trying to answer a question. I may need your help.
That's okay. I'll get to it after this section. All
Okay.
right. In regards to the actual prescriptive code and ways that you can actually meet the U factor, you have to be less than 0.123. So that's why we brought multi-layer into this as a less expensive way to meet that. So here's where you can scale back the thickness of the rigid board. And in order to meet the U factor, you have to have a minimum R1 continuous insulation incorporated into the solution. And this is what the calculation was based on. We have 8-inch unfilled block. It is stucco exterior. We have in this case, we're going to say it's rigid board. So that's going to be a 3/4 inch foam board, an 1 5/8 metal framing. You're going to do a multi-layer, the one that has 3 reflective air spaces, and then you're going to finish it off with drywall. And this is going to allow you to be at less than the 0.123. So that will meet the U factor requirement. So that is one method and allows you to go from that 1.5 inch thickness of board and the continuous insulation requirement on prescriptive R and scale that back to a 3/4 inch. So you give the end user more sellable or leasable space. All right, next. In regards to another solution, if you're looking at just meeting less than 0.151, now you can take another step back to a lower cost multi-layer reflective and go from the one that has 2 layers to the one that has a single layer. You're still, all the other components are still the same. You're with an 8-inch unfilled block, a stucco exterior, 1 5/8 metal framing, and I didn't mention it before, but the framing can be spaced 16-inch on center or 24-inch on center. The 3/4 inch foam board, and then the multi-layer that creates 2 reflective air spaces, and that will get you to less than 0.151. All right, next. Now, there is also the performance-based method. This is where you have a design standard you're trying to build to, and that has a certain energy savings level that you have to reach, and that is all calculated within the 2 softwares that Lisa mentioned previously, either Energy Gauge Summit or ComCheck when we're talking about commercial. And in regards to those 2 softwares, you basically are plugging in the values for your insulation materials, and you just keep tweaking your building envelope until you get to the energy savings level that you need to be at for your design standard. So in this case, you can use just strictly a multi-layer reflective on an 1 5/8 metal framing with CMU block, and you do not need continuous insulation. And you just plug in what would be the respective R value. In this case, it would be R 7.1. So that is an option for you in Florida. Oh, next, sorry, I'm trying to change it. I'm clicking on my keyboard. All right. So in regards to the other options you have available, obviously under performance, is you could again step back to R 5.1 on an 1 5/8 with the single layer product. And again, that's also a solution that you can use under the performance path. And again, all you're going to do is plug in 5.1 for the insulation value. Next. And then, of course, you could also do foam board, and you could do, you don't have to do it continuous. You can put it set between. So let's just say that's a metal hat channel. So you can just insert the foam board into between the metal hat channel framing and just go with the R value of that board and plug it into the software. Or you could go back to a continuous insulation, but you could scale it back to like 3/4 of an inch. And again, save some money on the cost of the insulation side of it. All right, next. And then these are just basically showing you some examples of the reports that you would get out of Energy Gauge Summit and ComCheck in order to show that you have met your requirements, and then can show those to the building code officials.
So the question was, and I lost the question, but it basically the R value of an 1 5/8 metal stud versus say 2x2 framing.
Yeah, there is obviously you have a negative impact from the framing itself when it comes to a U value calculation. But when you're just looking at R value of the insulation material, it's based on the air cavity and the section between the framing. So an R 7.1 and an inch and 5/8 is consistent, whether that would be a metal or a wood structure, but inch and a half because that tends, okay, let me go to an inch and a half because that's more common in both wood and metal. So inch and a half framing, it's going to be like the one product with the 2 layers of foil that has 3 reflective air spaces would generate a 6.5, whether it's on wood or on metal. When it comes to the flat R value. But when you're looking at a U value calculation, yes, there is a difference in how that impacts the end result.
Perfect. And I think the other one was to do with vapor barriers, making sure it doesn't hit both sides of the wall, but you may address that in this next chapter.
Oh, that's one thing I didn't mention. That is a very good question. The products that we're referring to as multi-layers in this presentation do have the option to be perforated or non-perforated. So you're going to be using the perforated versions in hot, humid climates like Florida because it will allow vapor transmission. And I think I'm going to hit on that again in the next section. And so they will allow vapor transmission, so you're not trapping moisture in the cavity. So any concerns with, having double vapor retarders, you don't have that concern with the insulation side of it anyways. In regards to, I can't answer the question from the standpoint of the foil face foam board. You'd have to look at their particular perm ratings to know exactly whether they're classified as a vapor retarder or not.
All right, we're good. All right, ready?
Okay, that the other one's for you, Lisa. I can't answer that one, so
Yeah.
we'll move on. All right, let's get into the vapor transmission and air leakage. So basically, we know that everything moves from high pressure to low pressure areas. And if you have any kind of opening or penetration in your envelope, it's going to look for that path of least resistance and move inward. So you got to make sure that you're making sure you have a good air sealing plan incorporated into your plans and documents so that you're helping address any potential for bulk moisture, to keep bulk moisture out of your building. It all comes with the design of the overall building as well, but anything you can do within the envelope to help address that, proper placement of air barriers, proper placement of vapor barriers. And like you said, when you get into the interior side of it, when it comes to insulating, just making sure you're not creating double vapor barriers and trapping moisture in your envelope. And then obviously paying attention to the penetrations in your exterior to make sure those are sealed up right. Okay, next.
Whoop, whoop.
Um, so, and again, I was mentioning this already, but when you're working in hot, humid climates, you don't want to trap that moisture in the interior envelope. So you want to use products that are permeable or semi-permeable so that and make that part of your moisture control strategy. So it helps promote moisture infiltration. So in other words, if some moisture does get in through the envelope, the air conditioning will pull it out of the envelope because the product is allowed to breathe. In other words, it allows vapor transmission. And then as far as vapor retarders, those would still be positioned on the exterior side of the envelope for the most part. Some building envelope consultants might have a different read on that, but it's not spelled out specifically in the code, but you sort of base it on your past experience with other projects, and of course use the consultants to help guide you based on the way your product is structured. What I mean by your product, your building is structured. All right, next. So as far as permeability, as I mentioned, all manufacturers should be willing to provide you with the perm rating of their materials, and that's so you understand how much it will breathe and allow moisture to pass through it. And again, those tests are done. It's a 24-hour standardized test, and it measures that amount of moisture in perms. And so this chart below shouldn't be new to anybody. It's basically the standard, rating of products from class 1 to vapor permeable as far as how much moisture they allow through. The first class is going to be a vapor retarder. It's virtually vapor impermeable. The second category, class 2, is where you may find a lot of the foam board products. Class 3 is going to be your more pervious products. You probably get into basically your fiberglass, and some fiberglass might even be permeable. I'm not really sure. But in regards to the multi-layer products that are perforated, those would fall into class 3. And they are totally suitable for applications in Florida. Next, I'm sorry. All right, so as far as, I get back to the air barrier and vapor barrier positioning, in Florida, we would recommend you put those vapor barriers on the exterior side as well as your air barriers. And this is just showing the proper positioning if you were in a hot, humid climate like Miami. But most of Florida is a hot, humid climate. So, all right, and learning objective number 4. We're going to get into the final section, focusing on strategies to make it a more sustainable, resilient, overall robust building envelope. And next, we're going to start with, these are the basic topics in this section. We're going to focus on reflective insulation, low environmental impact, low life cycle costs, sound attenuation, fire resistance, and resilient envelope. So in regards to reflective insulation and sustainability, the reason we're staying with reflective insulation is because it helps address radiant heat transfer, which obviously can improve the energy efficiency of your building. It also, just helps with the overall goals of being more sustainable on the energy efficiency level. So the other aspects that you can obtain with these materials is recycled content. Making sure that it helps you meet those requirements. You can get products that have no paper, no food for mold. There are paperless solutions. You can help reduce waste. Couple ways is a roll versus a board. A board is a bigger target on a project, so you could tend to get more damage. You will probably tend to have more waste from cuts and scraps in a board material than you will a roll material. The leftover roll material can be moved to another job site, like a new job or different job, or it can be left on site for future renovation or remodel. Products can be found locally manufactured within the state of Florida specifically. And then formaldehyde free, you can, assure that products don't have any added formaldehyde, which is one of those big VOC issues. And then of course you can look, and we've already talked about ways that you can save costs by adding R value with alternate materials, and scaling back some of your continuous insulation and combining it with other materials in a hybrid. So I think that takes care of my section, and Lisa, it's back to you to wrap us up.
All right, so here we have the inset chart, and it's talking about the embodied energy of building materials. And you can see everything's got an embodied energy. It's basically the weight of the product divided by the megajoules. So we're looking at concrete products, they're very low. Blocks anywhere from say 0.94 to maybe 1.2. Interesting, cement is definitely a little bit higher. It's in the 1 stage, depending on where we fall with the cement. Cement is a product that's in concrete products. Clay, for example, we're starting to get up there a little bit more. The reason clay is a little higher is strictly because of the drying process. I mentioned earlier, block gets humidity cured, brick gets fired in a kiln, so there you go. But then you start to see some of the other building materials, you really can get up there with the embodied energy. And what about that environmental impact? So just having that lower embodied energy, one of the reasons is because of excavating the materials, the raw materials, and then actually shipping them to the jobs or to the production site in order to produce the materials. So you try to always have raw materials as close to a manufacturing facility as possible. So low life cycle really implies yes, regionally produced products. I mean, one of the reasons why we produce so much block in the state of Florida is because we have limestone, and limestone is an excellent aggregate to put into the concrete masonry unit. There's some recycled materials available. I've done projects before where I've had recycled glass. I've had other recycled aggregates. The recycled glass, by the way, is not just glass. It goes through its own process too. Even things I mentioned in a previous presentation of using shell as an aggregate. When you're part of our industry, we're very respectful of our environment. I mean, we only have one. So many times that you will not see a lot of waste because that waste will be used for perhaps going to maybe there's a road base or something that can be used. Also, reuse and recycling. Many times you can repurpose a building. Not only can you repurpose, but if you have a building that's built out of a concrete masonry unit, you can actually tear down that unit. Now, clearly you're going to damage units, but you can actually clean off the mortar and use some of those products again. So think about like the old Chicago brick, how many times that's been used in its lifetime. So another area is sound attenuation, and this is more of a multifamily picture. But if you think about and maybe think outside of the box a little bit, when you have a smooth concrete masonry unit, sound can absorb a little bit within those cells, and they do make sound attenuating products on the market, but many times a lot of that might bounce a little bit. But if you can design with a little more of a textured product, you really have some very good sound attenuation. Now, another big factor, are CMU blocks non-combustible? Absolutely yes. And in fact, the insurance services offices, the ISO, they actually rate building materials. They rate them on a scale from 1 being the least fire resistance to 6 being the most fire resistant. And if you have a wall that is built with a concrete masonry unit and you have your floor and your roof with other non-combustible materials, you absolutely are going to get into that 6 rating. But many times, depending on your project, you're going to be over 5. But it is about balance, and it's important that you have that balance. So detection and suppression are considered more active systems. Something has to happen to trigger that. So your alarm would be your automatic detection system, and your fire sprinklers would be your automatic suppression system. But then you also have compartmentation, which is using non-combustibles such as concrete masonry, so you have a safe egress. And this is a passive system. Nothing is going to trigger anything. It's always there, but it will allow not only for patrons to get out safely, but for first responders to come in. So I do get asked quite a few times about the fire resistant ratings of a block and how do we determine this? So there's several different methods. There's the real world testing, which is ASTM 119. This actually is when you take product, you take it to a lab, a block wall is constructed, it is then contained, set on fire, and then they figure out how long before that wall is compromised. And there's various tests that they use. Sometimes there's like a heat test on how much heat is extending into the other side of the wall. Obviously, there's the test of if anything was to destroy that wall. But that is something that's very expensive, and you only do it occasionally. And typically, an 8x8x16 has a 1 hour given. But there are many instances where you can have a 2-hour fire rated 8x8x16. It's just the manufacturer needs to know. So if you Okay, so you have real world testing. You also have services like UL. That's another kind of a service. But honestly, you can compute your fire rating by equivalent thickness and aggregates. So I'm going to do the scientific method, if you may. If you have an 8-inch block that's your typical hollow block, so your face shell's about 1.25 inches thick, you have 3 webs. As long as your equivalent thickness is over 4, you will have a 2-hour fire rated block. Now, equivalent thickness is the measure of the volume of the concrete when you take out the core holes. So that's equivalent thickness. So it's equivalent thickness and it's the type of aggregate. So I mentioned a couple times the aggregate that's predominant in Florida is limestone. Now, sometimes you might have it mixed with some other things, but if you look at this limestone, the equivalent thickness, if you're at a 4.0, you will have a 2-hour rated block. Now, one of the reasons why UL doesn't always make sense, there's only maybe 5 manufacturers in the whole US that subscribe to that service. Unfortunately, it's expensive. They have to come inspect your plant and they have to have a representative there when the product's running. Do you need me?
No, I'm sorry.
Okay, so you may not, so you have a representative there. So they're paying for all of this. So by the time that concrete block gets to your project, you have tacked on quite a lot of surcharge because of all these extras, when all you have to do is a scientific calculation. Now, we all submit submittals and they all have test reports. Not all test reports have a line item that says the fire resistant rating, but all test reports will show you the equivalent thickness. So again, equivalent thickness and aggregates. Something I do want to point out though, expanded slag or pumice. So pumice is a lightweight aggregate. We do not mine it in Florida, but we bring it in all the time. We bring it in for the lightweight capabilities. It's a lightweight aggregate. We also bring it in for aesthetics. But if you look at this chart, here we have our 2-hour rating. Look at this. If you have a block that's a lightweight block, your equivalent thickness only has to be 3.2. So there's certainly some very good components of building with lightweight block as well. So just depending on what your requirements are for your job. Jan, you want to talk about the thermal
Yes.
materials?
So this is just real quick. I wanted to show you a section of the code that relates to single and multi-layer reflective foil installations. This is just allowing you to use Class B insulation materials in type 3, 4, and 5 structures. So this is the section of code that refers to that. And if you could go to the next page, Lisa, that you'll see here where it gets real specific. And the reason for this is that because the products are enclosed or concealed within the building envelope itself, and then they're in direct contact with the drywall because they're attached to the framing, that allows you to use the Class B version in type 3, 4, and 5. Now, there is also Class A available, but that's just to let you know you do have that option in type 3, 4, and 5 structures. Okay, that's it.
All right. So lastly, we're going to talk about the mass wall assemblies and the resilient envelope. So I know there's a number of design strategies that I see implemented quite often. Maybe the building size reduction, both volume and the airspace. Sometimes just intelligent orientation. So we're actually taking advantage of natural heating and cooling. There's been improvements in air tightness within the wall systems. Maybe higher RR values because of products and just overall design, and improvement of the utilization of thermal mass. All of these really play a huge part in gaining that resilient transition. So interesting, the NIBS, National Institute of Building Sciences, they put together a report and they do it every 5 or 6 years. And they're talking about resiliencies. How quick can we recover? And remember, the definition of resiliency is the capacity to anticipate and minimize the potential destructive forces, which could either be man-made or natural. And although our codes are progressing to really go a step above, it really, our codes today don't assure resiliency. Now we work on it, and certain projects we're able to expand more than others. But quite honestly, it's up to you as the designers to be the advocate. And we realize, I mean, budgets are budgets. So the codes are honestly the minimum building requirements. They're aiming to save lives, not necessarily saving the buildings so they can be usable. And we all want to be able to jump back as quick as possible. So in 2018, the NIBS put out a report that if you spent even $1 on resilient building and construction, you could save over $6 in recovery costs. Well, they had a recent one come out in 2022. And trust me, this slide was recent. I can't believe it's already 2024. But for every dollar that's spent on resilient building and construction, it's now up to $11 in recovery cost. And those recovery costs, you know, it's property damage, it's the disruption of data life, it's everything. And as we all know, when there is a disaster, everybody needs something right away. So just a little bit of planning, if at all possible, you know, can really help. So just to wrap up, designing an effective yet economical thermal envelope is absolutely paramount. We addressed energy consumption and showed you if we just continue on our progressive path, how we'll ultimately save not only money, but hundreds of CO2 emissions, something else that we really need to keep in mind. Also, proper insulating of the mass walls will not only save cost and meet the codes, but will provide a more energy efficient building envelope. We spoke about addressing vapor transmission and air leakage and how this really will improve your building's envelope performance. And lastly, just the resiliency has joined sustainability as an essential characteristic of new construction, and it really needs to be the buzzword. And some of those strategies are suitable building materials, having the right product for the right project, not only good design details, but absolutely making sure that the proper construction procedures are followed in the field, and that design intent is passed on to the people in the field, and then overall progressive building codes. So we appreciate it. That is our presentation for today.
Hey, Lisa, I think you may have a couple questions.
All right, let me just take a peek.
Yeah, they weren't anything I could answer.
Okay, so the situation: existing building with an uninsulated 8-inch concrete wall, exterior highly textured, making adding insulation on the exterior expensive. If adding insulation on the interior, what would you recommend for a vapor barrier, and where would you locate it? Clear repellent on building exterior? Well, honestly, I would definitely add the insulation on the interior because your exterior is exposed and it's textured and it's already got the design intent there. But Jan, what are your thoughts? I mean, the vapor barrier in my mind would be what are your thoughts, Jan?
In regards to the actual vapor barrier, I
Yes.
would not, I mean, I would keep it on the exterior side. That's where we really want it in a hot, humid climate.
So I did one of them, I'm sorry, I just missed a question, but can solar heating systems be used to reduce the carbon fuel for the dyeing process or the drying process? So I'm not sure if you're referring to the drying process of brick. I'm not quite sure, but I will tell you, I mean, most of the times it's natural gas, just because the kilns, and I could be going the wrong path, so my apologies. Oh, for cement products. Okay, so yes and no. You want the humidity. It's actually, there is no heat. It's humidity. So you've got an encapsulated coffin, if you may, where the blocks go in to dry, and then you have either a door or a tarp or something to enclose it. So it's not encroaching on any other energies at this time. It's strictly just humidity.
As
And
far
then,
as, I'm sorry, are you done?
yeah, go right ahead.
I was gonna say, as far as the question about spray foam insulation, that is not considered continuous insulation. It is between the framing, so it would not be a continuous insulation material. And you would have to run calculations in order to determine if it's going to get you to less than 0.123 by combining the spray foam with a foil face type product. So if you do a multi-layer and spray foam, you're going to have to run some calculations to figure that out, to determine, which spray foam based on R value that's achieved with the spray foam itself. And then the airspace that's left, you usually have to leave. You probably have to go with the 1.5 inch airspace minimum, which would add an R 6.5 with the multi-layer reflective, and then it would be plus whatever the R value is for the spray foam. And then depending on the type of framing you use, that could add to, like if it's metal, you're going to have to, work through making up for that otherwise in the envelope. So you really have to like design your whole wall assembly and to figure that out. Unless now I stand corrected. If you're using performance method, then you definitely could do that and just create a hybrid. You just have to leave, if you want to do a multi-layer plus a spray foam, then you have to leave a designated airspace for the multi-layer of depending on what R value you're trying to get out of the multi-layer. So if you want to give me a call directly on a specific application, I can walk you through it.